So here in the beginning of our study of reasoning and proof, we've talked about inductive reasoning. Inductive reasoning is where we're looking for a pattern in something. And then as we see that pattern, we might make a conjecture. That conjecture is a conclusion that we're making regarding that pattern, maybe in the form of prediction or something else. But if a conjecture is true for all cases, then you've got to prove that it's true. And if you can find an example that renders the conjecture false, then you have a counterexample. And a counterexample, just one counterexample, can make the entire conjecture not true. So a counterexample is something that would indicate that the conjecture is not true. So here we got a couple of examples, and we're asked to find counterexamples. So first up, we have here this conjecture. If n is a real number, then negative n or minus n is a negative number. So now on the surface, we might think that seems to be true. If n is a real number, then negative n is a negative number. But what are real numbers? Well, real numbers can be both positive numbers and negative numbers. Integers, as an example, is a classification of real numbers, positive and negative numbers. So let's say, well, what if n equals negative 3? Negative 3 is a real number. Then would negative n give us a negative number? Well, no, that would mean that we'd have negative 3. And negative 3 is positive 3. So here we have given a counterexample to this conclusion. If n is a real number, then negative n is a negative number. Because negative 3 is a real number, but the negative of negative 3 is actually positive 3. Therefore, we have given a counterexample. Let's look at the second example here. We've got a conjecture here. If angle ABC is congruent, remember this little symbol right here means congruent, to angle DBE, then ABC and DBE, angle DBE, are vertical angles. Now, we've already discovered that vertical angles are in fact congruent. But what creates a vertical angle? Well, a vertical angle is created when two lines intersect, and therefore we've got vertical angles. These two here, as an example, would be vertical angles of those two lines or segments or rays intersecting each other. But what might be a counterexample to this conjecture? Let's see. Let's suppose that we had something like this. Whoop. No, not like that. Let me draw this differently. Now, would that mean that these two angles, and let's say that these two angles are in fact congruent, but are they vertical angles? That looks too much like, let me get this right. Let me see here. So there would be one, and let's say we got another one that's coming more like that. Okay. And let's say that these two angles are in fact congruent, but would we consider them to be vertical angles? Well, no, because I'm seeing a jog right here. This one comes down and then it goes like that. That's not a line. That's not two lines intersecting each other. It's fairly close to that, but they are not, in fact, vertical angles, even though they may be congruent. So we cannot assume. Well, let me do this another way. Give another example of this that might actually be better. Let's say I've got an angle here, and I've got an angle here. And these two angles are congruent. But they're certainly not vertical angles, are they? They're two complete separate angles. Those are not two lines intersecting with each other. So therefore, we got a counterexample to this conjecture about angle ABC and angle DBE. Because they are congruent, that they must be vertical angles. That does not necessarily have to be true, and therefore that conjecture is rendered false.